A cube is heated up in an oven and then placed outside to cool. The larger the volume of the cube, V, the slower the cube cools down. And the larger the temperature difference between the cube and its environment, delta T, the faster the cube cools down. What is a possible equation for the rate at which the cube cools down? In this problem, we're trying to figure out which of these four equations makes the most sense so as to describe the rate at which the cube cools down. The variables we have to work with here are V, the volume of the cube, and delta T, the temperature difference. And we'll assign variable R to be the rate at which the cube cools. The coefficients of 2 and 6 we see in the possible solutions are not important. What we're interested in is how do these variables V and delta T affect the cooling rate. The problem states that the larger the volume of the cube, the slower the cooling rate, R. Therefore, this would result in an inverse correlation, so as the volume increases, the cooling rate decreases, and vice versa. We also know that the cooling rates increase as the temperature difference increases. This would be a direct correlation, which means we'll put the delta T variable in the numerator of the equation for cooling rate. Of the possible solutions, we're searching for one where the delta T term is in the numerator and the volume term is in the denominator. This occurs only in the solution 2 delta T divided by V. So the answer is A.